Okay, I'll put this aside for the moment. Anyway, I wanted to, to really quickly show you that, that the resistor values I'm choosing, again, these are the resistor values that I'm, that are, again, ballpark. This is the target current per LED. So, and again, for this up here, we're only dealing with those inner 3 LEDs, and this applies to only to the outer 3 LEDs. So you can see, based on a current and the fact that this is a 12-volt double stack candle with 2.4 amp hours for a fully charged set of batteries, like Energizers or something, I assume. These are the hours of life. Now, 150 ohm would be our highest setting for a single circuit, because that provides about 22.67 milliamps, which is very close to the 25 milliamp maximum rating of these Cree LEDs. At that rate, it would last 4.4 days with just a single circuit on. Now, if you also happen to switch the other circuit on too, the flashlight mode circuit, then that cuts that in half. But that can be switched on independently of this. In other words, this can be totally on, and since we're powering this, totally off, and since we're powering this from a totally separate push button now, it can last either 4.4 days with just those outer 3 LEDs on, running full blast, or 2.2 days of battery life with both, all 6 LEDs on full blast. So, and of course you can also do combinations too, run these at full blast and these at half power to get, other variations in light output, but I won't really consider those. But at any rate, so, and keep in mind, like I said, the interesting thing about this candle is my other candle uses 4 AA batteries, okay? As a result, it's got 2 separate LED circuits, with even though it's only got 2 LEDs, because I can really only power safely 1 LED per circuit. Here, since it's 12 volts, I can actually safely power 3 LEDs per circuit. So what that means is that we get the same exact current. The target currents are pretty much the same, as the flashlight that I had up here. The only difference is that the longevity of every current setting is pretty much doubled down here. So from what it is here, so it pretty much doubles the lifespan, while at the same time increasing the light output by 1.5 times. And that's partly because of the fact that we're using our batteries a little more efficiently here. Up here, I'm basing it off of 4 AA batteries, 6 volts worth of batteries. Well, our LEDs are dropping generally somewhere around 3 volts. So half the battery life is going to waste. Whereas here, we're dropping a good 9 volts at least, and only 3 volts of the battery, 3 volts of the battery is still going to waste, but, the thing is that 9 volts isn't. So it's a lot more efficient. Now, of course, we could put it, like I said elsewhere, we could just power one of these LEDs off 2 AA batteries, but if we did that, we're going to have no real control over the current. So if you're happy with very low current ratings, and current draws off of things, yeah, you can probably get away with 3 volts, but you may not be able to drive the things up to full blast, and it's luck of the draw in production as to whether you could or not. And if you did decide under those circumstances to use like rechargeable batteries, they actually run at a lower voltage, about 1.2 volts per cell instead of 1.5 volts. So you actually couldn't even power the thing off rechargeables. Now you could go to 3 AA's, and I've done that with another experimental prototype I've done since I started making this film. That gives you a little more overhead, and it's workable. So that's a little more efficient. At least you're not using as many batteries, but you don't really get any other benefits out of it other than you're saving 1 battery. But with 4 batteries, you're going to have a better overall lifespan or faithfulness to the target current. because see, as time goes on, your battery voltage, will actually tend to diminish in a curve kind of like this, and then it falls off kind of sharply as the batteries die. So it's something almost like a sideways S curve. But the point is that voltage falls, so too will your current through your LED. So there'll be a pretty quick drop in light output for a while. For the first X number of hours you're using it, depending on your setting. But then it'll kind of plateau out more or less and be fairly steady for quite a while, and then fall toward the end. Well, if we ran this at a lower voltage, you would see your LED current fall off a lot more and be a lot more sensitive to that curve than it is with 4 batteries instead of 3. But again, this uses 8 batteries, so in some ways it'll be a little more sensitive, but still it has a pretty good immunity curve. At 3 volts, that's not bad. And we'll get the added benefit of it again, basically doubling your battery life while at the same time multiplying your light output by 1.5 times for the exact same amount of input current. So that's what's cool. So you got all these standard deals, but like ratings, but like my other light, in its lowest setting would last 172 days, on quote-unquote nighttime mode. This is 247, so that's about doubled the time, but for 1.5 times the light output. So but now our new sleepy time mode, right here, will last you about 2.67 years. In other words, 970 days, or 23,000 hours, because we're only running it at about 1/10 of a milliamp. So as long as those are the only LEDs you're using, that's what kind of lifespan you can get out of it, and it's pretty remarkable. So anyway, that's kind of what I'm doing with that, just to kind of fill you into the various settings on these switches. But like I said, back to this, like I said, we got our relay kind of nestled up in there now, and go ahead and light back up the electronics layer 2. So that solves our crowding problem, with this board here, by taking that relay out of the equation. I'll call this relay. So we hide it if we need to. It's got those curves on it right now. I'm going to need to go ahead and move those to the LED board retainer layer, I think. Well, hold on. I guess I need a new layer. Switchboard retainer. Which is right below the guide channel. I'll do these lines to that layer. So, anyway, with that I can hide her. What else disappeared? So, hide a relay there, and like I said, for this channel, let me, and this I'm going to have to think a little bit about. Because let's see, we're going to have this well here. We know that our, I'm about to delete these damn curves. But we know, you know, we're going to have this thick of a, you know, of a piece mating, you know, with this piece down here, you know, whatever we're going to house the circuit board in. You know, the circuit board is going to lay on the top of whatever this is going to be. And again, I was kind of playing with the idea that, you know, since this piece we're about to do is going to be printed from the bottom up as well, that it could actually have a concentric ring in it, but that might be kind of hard to pull off given what we're doing here. So I'm still thinking about that. Because see, our circuit board, you know, because we don't have to necessarily fully follow the wall thickness, you know, on this piece down below. However, if we're going to make a piece that, you know, concentrically joins on the inside of this, you know, that could be tricky. And the other thing that's going to be tricky is the fact that, you know, I wanted a skirt to come down from this piece to join up here. So I may actually have to, believe it or not, print an intermediate ring to actually adapt this piece to that piece. Could be a little screwy. If I did, I don't think that would work very well. Because I'm really reluctant to actually try to print a bridge across here, because that can go squirrely on us in a hurry. It actually causes the print to mess up trying to bridge it, especially along a curve like that. I mean, I don't think we can get away with a bridge that way, 3D printing wise. So in other words, you know, I don't think I can just actually print in free air over the switch, because the switch has got to stick out, you know, through the side of the housing, you know, along this length, so you can actuate it. And it's going to have to be a little wider than the switch travel too, just to make sure you got tolerance for error in it. But I don't think I can just bridge this, especially along a curve. So that means, you know, the top of it has to be open. Well, it's a bit of a problem, because that means you'll see like the, you know, the edge of the exposed circuit board and everything like that through the switch well, and that's not very attractive. Normally I have the piece up above it, you know, coming in, and it's usually printed from the top down, so I'm usually able to put a feature on it, you know, to you know, a switch skirt, you know, to actually cover that opening on the top side of the switch. But I don't know if I'm going to be able to get away with that here without it getting kind of elaborate. And because again, I could print a little, you know, intermediate ring that actually performs that function, but it'll have to be a top-down print. And again, I was talking about having an alignment into this thing, you know, again, because trying to get these things concentric can be a bit of a headache. And there's a bit of an advantage mechanically, from a mechanical strength standpoint, to have a ring like that too. But I don't know. I may just have to forget the ring part and just try to glue these things together directly. But I mean, I'm going to still have to have some kind of skirt for that switch. So again, I think we're going to end up needing an adapter for whatever whatever we do to adapt this part to this part, unfortunately. So we're probably going to need yet another intermediate layer here for another intermediate piece. That's what I'm thinking anyway. See, our circuit board, you know, is probably going to have to follow kind of this line here. So I'll put that on PCB 2. Anyway, so that will probably be our basic circuit board layout there. And with this, you know, we got plenty of room to position a few resistors and the like. Let's see. It's going to be tight. Something like that would be a layout, but so that's kind of what I'm going to focus on, I think, right now. Is getting this in basic position somewhere. I'll figure out where to put that exactly later. That gets rid of that, but we know what our outer diameter is going to be. That's our circuit board, which has got enough real estate to accommodate all of our pins and everything, so it'll have to have a retainer. something like that in it, and you know, just to basically capture the circuit board. Then its walls, you know, will go from, you know, will be these two. Its outer walls above the circuit board will come up like that, you know, around it, and then mate to whatever we're going to do for a switch skirt. Whatever adapter we have to make these that channel guide to this part down here. Now, I'll probably just take both of these rings here, and move it just a touch above our circuit board. So it's 204 mil. Bring it about here, you know, because whatever adapter we're going to put will, you know, basically help, you know, allow for some room, you know, for the solder joints and all that. But, like I said, before we do any of that, I've got to go in and provide some kind of a switch well here. It's starting to get annoying. Okay. Now this I'm going to put I'm going to leave some pretty generous tolerance around it. This is fine. I drew this earlier and we imported it. That's from a previous switch well on a previous project, so I know it'll work. Okay, this wall will be something like that, and again, this is below board, so you know these will run into it. So will these. I could go with less than a 1/16 of an inch, I suppose, but you know, this is going to eat into it, so that's a little bit of a problem. Let me think. Little closer tolerance here. Let's see what I can get away with. still really nip into that. I'll probably make this a solid piece with this. Yeah. I got kind of a headache today. I probably shouldn't be doing this stuff. See, this well right here is going to be much deeper. It's going to go the depth of the switch, whereas this only needs to go to about here. So then I can turn it into a solid. Again, it's a 3D print. Okay, so it joins those two up. Probably don't need this separator here. So that would leave us with a solid wall that we can join up with this circle on the outside. do something I rarely do. And that's why I rarely do it. Messes everything up. Actually, I don't know why I did that. Yeah, I don't know what the hell's going on. That's why I don't like messing with this, because like I said, these tools are kind of funky, and you know, trying to move your C-plane, you know. Okay. Anyway, that seems to have set our C-plane down to our circles, so I'm getting sick of drawing curves out in the middle of nowhere and having it not line up. Okay, so in theory, I should be able to join these curves and make it work now. Go. Okay, so basically that's the piece we're going to cut out of the bottom, and then we're going to have to cut these pieces out here for the switch wells, and I don't know if that'll create some kind of a problem or not, if I should trim these or not, but yeah, I probably will. First I'll save these just in case. Let's see. Okay, so that's our switch wells, you know, for both the switches. Now this, we got to do something a little different with, because this is the outer edge, and we're going to have a button that comes in here, but I can flatten that out, maybe. So I might go ahead and just flatten it out and treat it, because I'm going to have to print my own button, because the switch is, you know, just, you know, not long enough to, you know, stick out through the side of the housing, so I've got to print my own plastic button. I'll probably make it circular, which we should be able to get away with, so I probably don't need this piece. I'll just save it for later. But I'll go ahead and just keep everything flat. That'll keep things nice and simple. Could actually do is this. Bring it like that, and then chamfer the curve here. Well, actually, I'll explore middle. See how that looks. I'll go a little more than, what the hell? So that'll be our cutout, and here we'll have a button. It's got to be within this limit. Right there. Well, let me start over. Just shy of that. I can always sand that down if the tolerances are too close, because I'd like some actual positive pressure on that button when I have this thing in here a little bit. So I'll bring it to a pretty close tolerance. Anyway, that gives me kind of a reference right there. You know what we're after diametrically. Now let me come and draw a circle. Well, let's see. Okay, and let me draw a circle for this. Like I said, it's going to end up being a pretty small button if I do it this way, though. Okay, so this is, well, okay, 437 mil diameter. So I'll take it about, yeah, so it's 437, 387. Okay, so that'll be the hole for it. Okay, so this is 487. Let me give this tolerance like that. So that'll be our button diameter right there, about 337 mil, so it's certainly well over a quarter of an inch, almost 3/8. That's a pretty good size for an actual physical push button. That'll be the hole for the push button that we're going to drill in this, not drill, but drill on the side of the part we're about to create. And that'll be the inner layer of the push button itself. So, let's move these curves up here. Get rid of our guide. Okay. Now this button right here, again, I'm not going to really allow it any tolerance. Well, I'll allow it a little bit. 0.085. Gotta use negative values. Okay, that's the actual button itself, and we're going to want that to stick out a ways. So, you know, well beyond the travel of the button, so I want to stick out of the housing considerably more than that. Take into account, you know, you don't want your finger going into a hole or whatever. I mean, it's good to have a positive contact on it at all times. Okay, that's got that. And I'll weld. Really? Seriously? Weld these two together. And I might go ahead and try to put a fillet around the edge here. 0.08, something like that. So, give us a bit of a curved surface to it, so that ought to work. So that'd be our push button right there. Okay. Basically, you know, at this point in time, we should be able to start carving things up, I think. Oh, well, I do need to look at this real quick. Like I said, we got this thing here, and like I said, it's going to actually stick out a little bit. So again, I need to write a really generous allowance here, like 50 mil or something like that per side. It'll leave a bit of an unsightly gap in it, but you know, we got a lot of tolerancing issues with all these parts fitting in there. It doesn't hurt to have a little bit of a loose tolerance in it. Although I may do a little closer than that. Do about 40 mil. But again, like I said, I kind of want to do two versions of this because I still may change my mind about this whole, you know, this whole nightlight thing, but or emergency light circuit thing. So, so once I extrude this part and get it carved up, this will be the last thing I do is cut this out of it. So, although for this I'm going to need a skirt too, actually, now that I think about it. Because that's the other thing, I'm going to need a skirt for this as well. So let me copy that there and grab these things and hide them. All these things and hide them. Okay. Scoop this up just a wee tad. That gives us more than enough generous allowance around the perimeter of these switches. Okay. I got that drawn in there. I also will ultimately need to take into account skirting parameters. So let me go ahead and say take this to 0.028 or something like that. And draw that around. And this will be, you know, part of our skirt for the top. I'll go ahead and keep with the standard 0.025. I've had pretty good luck with it, I think. But we're also going to need something similar. We won't need a skirt over here because that's actually going to be like it is, but I need to unhide our... Okay. For right now, I'm just going to go ahead and leave these things, you know, right in this neck of the woods. So I don't need this anymore. Let me unhide everything. Okay, but I do need to come over to this and, you know, remember we got this thing here with a pretty good free tolerance around it. But like I said, we're probably going to want some kind of skirt on it as well, so that skirt will top out. It's got to be, you know, well below the switch by 35 mil. So something like about, you know, about like that. And this, if you recall, you know, is for a skirt, and that 2 is going to have to be in here, something like that. So we're going to have to go and give it a tolerance, something like that, so it doesn't stick down too far. You don't want it running into anything. So that ought to do it. Okay. Now when we're ready, I'm leaving these here because it's just, I mean, it's not a problem to extrude it though, but usually just make one set of curves, extrude the solids, and then I rotate them and copy them. So I end up with a bunch of curves everywhere to get rid of. Okay, but at this point I should be able to go ahead and extrude our base. Now it's got to, be lower than this, which is already a pretty healthy, 3/4 of an inch. So I'll take it to minus 0.825, I think. Okay, so that's going to be our basic carrier. Let's say frail. Okay, I screwed up. This curve here actually is for a circuit board. This curve here, that's joining up with this, we actually need to have that act like a a shelf of sorts for a circuit board to sit on, and we're going to make sure it's not going to interfere with any solder joints or anything anywhere on here. So that's one of the things, it's taking us a little close. So it's going to have to come out to about right like that, and that's not giving us very much room for the circuit board to sit on, but it can actually sit on our little wall here that we're going to have. And it actually only travels around here, though, to some extent. So hold on a minute. I think we can stick with that shelf. This one I'm going to have to nip into. So that's our new curve, because that's going to be cut below this, because that's our circuit board and circuit board outline layer, and that's the inner wall. That inner wall is going to come down here, to at least something like, just like I said, a little below this. 287, and I'll just put it like right there. So we can trim this sucker out, and that's got our basic circuit board shelf there. But we don't have anything below it yet. Now this right here, this section here. Now first let me point out, for our little switch here, we don't need any kind of retainer or anything. I mean, I don't need any kind of a backing wall. See, I needed a backing wall on this switch because we got this button that we're going to be pushing against it, so it's got to have something positive to prevent the button's leads from being bent over. So it's got to have something for a positive force to go up against. So that's why we had to extend this wall over here. And this wall here is mostly just to keep the circuit board orientated properly. So when you push a button like this, or slide a switch, it doesn't like rotate the circuit board instead. So that's part of the reason we put a retainer wall around the switch wells. Or when we made the switch wells, I mean. Now, of course, right up here, we've definitely got an interference, and, you know, again, this is going to be a little convoluted when it comes to actually doing the circuit board route. You know, hopefully not too bad, but we'll see. I can always move things around later on that. But at this point, you know, this piece here, you know, we want to pretty much just burrow its way completely through the housing. So again, let me okay, so now when I remove the PCB, you see where we're at. Okay, now at this point, you know, I need to take this up here, and it doesn't hurt for it to be deeper than the switch by an arbitrary amount. And then let's see, I gotta do the same thing with this. And this actually could go completely through too. I mean, there's no reason for it to stop at the bottom of that necessarily. But I'll probably actually bottom it out here. Because like I said, for that matter, I mean, this actually could, you know, extend clear to the bottom too. I mean, there's really no reason to put a bottom on it per se. But on this, I'd kind of rather put a bottom on it because of how it interacts with this other well. So you know, again, given how much this is going to nip into the, you know, how close this distance is going to be, that's a very, very tiny distance right there. So I'll go ahead and keep that as it is. And this, I'm kind of thinking again about bottoming out, although I don't know. I'm probably going to go ahead and extend this just clear through it. You know, this cookie cutter right through it. Okay. That provides us our basic wells there, and again, since we're going to have an adapter that glues to this, to adapt to that other piece, you know, that's all nice and dandy, although we might even not need that really, but again, I'm still not done yet, but you know, but we do need it. We need it because we need a skirt. So strike that comment. But like I said, looking at this from the bottom, you see we don't have any holes carved or buttons or anything yet. This goes clear through, and our slide switches are retained up in there. At this point, I want to go ahead and copy and save one of these primitives. So I got a, you know, piece in case I mess up and have to come back. That's what I, you know, said kind of sucks about this program, is that you have to redo everything. That's why it pays to think ahead sometimes on a part like this and actually save a more primitive copy, because I'm probably going to save another copy later too, with like this hole and this hole and this hole drilled in it, but not this hole. But again, in case I forget to do that, well, you know, I've at least got this more primitive version that I don't have to start completely from scratch with again. Okay, but that's what we'll do here in a second. Let me go to the bathroom. pull it back down again, but try to get at least one more. Okay, alright, let's drill some holes. Let's see. Okay, so that's our button. Like I said, this is the hole we're going to be pulling through this. So, go ahead and knock that out. Okay, voila. There's our buttonhole with our button inside of it. And you can see how, this switch here, is spring loaded, so it's, got enough force to actually keep that thing in there. And this button will print from, this will be the bottom layer, this top layer, by the way, when 3D printing. But, the button, there's enough room to actually take this button, as you can see, and actually, kind of lower it into the hole, lower it into this well, and then, kind of guide it into place, and then you put the switch in behind it on the circuit board, and the spring-loaded action will kind of, keep it retained in there so it won't fall out. Okay. Now we're going to take a look at, remember this is for our skirt, we're saving that for later, but this is the actual hole we need to cut out for the switches. And that's why I positioned it here, because we don't want it cutting through our wall here. We just want it cutting through this outer wall. So, okay. And that's got that. Now you start to see why we need a skirt here, because otherwise if we just glued this to this piece here directly, there'd be one heck of a gap there, wouldn't you agree? So that'd be rather unsightly. So that's why we need a new an adapter that goes from this piece to this piece. And again, it can be flat bottomed or whatever we want to do, but we just need an adapter that goes between these two pieces and joins them, but also provides a little skirt that pops down below this, and later this as well. But anyway, like I said, at this point, if I decided to do one of these devices, without the little power failure thing in it, now's a good time to actually copy and save one of these devices, or one of these parts here. Before I go trimming holes out of it. So, that's what this is for. It's the hole to trim out of it. Let me move it so it doesn't interfere with anything. I'll grab this and remove that. So, and that's why we need a bit of a skirt up here as well. Let me turn on the circuit board, because otherwise the circuit board would actually appear, through the opening, etc. It'd be rather unsightly. So that's the next task, is to make an adapter ring with a skirt on it. It joins with that. meld these two together, and that'll get us where we want to be. So let's see what's, I don't need these curves here anymore. Well, actually it's not true. I'll just leave them for the time being because we still need some of these for a skirt to give us an idea on it. Trying to size up how we're going to bond this. Because this ring, we don't want to interfere with any solder joints. Probably arguably should have made that a little longer than I did then. Let me try this. I rarely use this command, but again, Rhino 5 has a much better version of this in it. It's got all three surfaces, so let me see if we can, by chance, get away with extruding this sucker. I'm just going to pull it up an arbitrary amount just so it's definitely clear of any solder joints if this works. It's really not giving me an idea of how long, so again, this was a bonus tool, so I think. Alright, let's see if that worked. I don't know, that may have messed things up. Let me undo it. You can see how smooth this is right now, and let me extend it. It seems like it may have made it a little more primitive. See, it seems like there are fewer polygons in this than there are this. It looks a little rougher, which means that we could end up with something that's not quite working right. It implies that it changed the type of object this is and maybe made it into a mesh or something. I don't know. That's why I rarely use commands like that, because they screw things up. In order to correct this, I'd have to go and redraw the whole part. That's what sucks about this kind of a program. I'd have to go redraw the whole freaking thing. Everything I just did for the last hour I'd have to go redo just to make that longer, because this program kind of bites when it comes to things like that. Again, Rhino 5 doesn't have that problem. This program does. So it just really sucks that you are kind of stuck with it. There's no real good solution in this program. Just these guys were, I don't know what the hell they were thinking when they made this thing, but there are definitely better programs out there for this sort of thing, including the new version of Rhino. So That's why programs like this, though, aren't particularly good for doing this kind of design, because it's just pretty much impossible to go modify it. I mean, it's just, because again, you're lucky to be able to get this far with it, with Boolean operations not seizing on you and failing and everything else. So going and trying to further modify them, it's pretty much out of the question. At any rate, I'm basically stuck with it. I should have made this thing, again, a little deeper, so that it was fully above the solder joints. That would have given me a little less of a headache at this stage. Because what I'm going to have to do is I'm going to have to come up with something that, basically follows this outline, because I still can't be, I can't come up with something that, is covering those solder joints in any way. So, but I guess, yeah, that's the inner shelf. No, let me hide that damn thing. Okay, but now see, the inner shelf is here. So along here was sort of an outer wall. I'll probably just make this into an inner ring and follow. Oh my God. That's what happens when you throw things under your junk layer a lot. I'll probably take this and extend that out as a surface. And I'll take this, use this for outer guide ring, but the question becomes, well, how do I want to pursue these skirts? Do I want to cut them out of this solid? Actually, probably just going to cookie cutter it. Let me just do it this way. Okay, now the length of the ring, let me light up that this again. Okay, boy, that's following it close. Yeah, it's got to be flat anyway, so it doesn't really matter. Okay, yeah. Alright, like I said, this is going to be flat, so I just need it to act as a skirt ring, so I'll just arbitrarily make it 0.1 inch, a tenth of an inch. Then let me go and cut this sucker out. So it's giving us that part there. Although again, we're going over solder joints, so I'm going to really have to cut this sucker out too. And this sucker. So it basically just replicated the pattern. On the other hand, hell, I don't need this per se. Really, now do I? Although it would act like a good circuit board retainer though, but we really don't need this stuff over it because, you know, it's not really doing much. Let me look at this. But it will help hold the circuit board in though once we've got that in place. And again, these little pins here, I always cut them off of these switches, so they're really not going to be a soldering factor. Never even drill holes for them. I just cut them off with wire nips. But yeah, I think what I'll do is this. Let me circle kind of like this. In fact, I might actually come here so we get some benefit. Mechanical hold down. Okay, so basically it gives us a couple little fingers that stick out there to kind of keep this thing in place, you know, without really obstructing any solder joints or anything. So, but it still will act as a keep, so the circuit board won't just kind of float around up in there for some arbitrary reason. So, okay. Anyway, this ring is what we'll end up attaching our skirts to. But like I said, you know, we got this going down here. Okay, so what I need to do is take this curve here and extend it downward to our deepest skirt level. Which I can hardly see amidst all this mess. Let's see, which one is the deepest? Let me see first. Okay, we don't need that one anymore. So let me move that out of my way. We don't need this one anymore because that's for our cutout for a power jack, but this is for a skirt and this is for a skirt. So it's really that one we need to adhere to. Oh, come on, you piece of junk. Okay. So that would be about the bottom, the lowest skirt. Okay. Now, I'm going to move these down slightly, or that one down slightly. But this other skirt's at a different level, so that creates a, well, we'll just have to do it again. So let's just deal with this one first. Let me extend this out like that and get rid of that curve. Now let me take this sucker here and grab the cylinder we just created and do a Boolean Union. and what that should have done, if we can find it, is created a piece like that, which is too thick. Okay, yeah, that's because I didn't do it right. I've got two. Okay, so we got this curve here, which is important, but I got to go define, because I've yet to do that, I've got to go define what our inner curve is going to be here. You know, which I have not actually done this yet at all. Let's see. Like I said, doing pieces like this is really complicated. That's why it's a big headache to try to get this done. Let me just base it off this curve and go in here, 0.0. That might be a little close for comfort, though. It'll be interesting to see if this Boolean Union works. Oh, shite. Well, actually, I don't. Yeah. Yeah, I guess I can skirt it. I'll make the outer wall about 40 mil. And we'll go with a 20 mil tolerance will put us there. I mean, that's hardly any real discrepancy between these two. About 11 mil. Let me just do it this way. About 0.032, and then we'll come in 0.02. 0.022. Hope that fits. Okay. Okay. Go ahead and get rid of this. Oh, jeepers. Jeepers. Yeah, this is going to be tricky. To get this to work right. Let's see. Okay, now I'm going to take this minus 0.1 2, you know, approximately 1/8 of an inch down into that. And then I'm going to take this, pretty much the same exact distance, and then I'm going to go take this, incremental save, try to Boolean subtract that, which it didn't work, so that doesn't surprise me. So, see, that's what I'm saying. That's what kind of a mess this software is. It's just kind of a joke, really. I mean, you can do a lot with it, but, you know, that was good for 2006, but, you know, I'll tell you. The program more often than not will stop you in your tracks, so due to stuff like that, you know, it can't, you know, do a simple Boolean difference here. Under a whole lot of different circumstances, by the way. Well, let me try to see if I can do it this way. For this piece, it might just be a face problem. Sometimes it is. Let me see if I can just extend it up there and get rid of it this way. Nope. That's why I say with this program, you know, you just usually can't do what you want to do, basically. It's just, it sucks. You know, it would have been okay, probably, if we'd done this first before cutting any of these holes. But now all these holes and this complexities in it, you know, you just can't cut it anymore. So, because like I said, you know, this really is not that complex of a shape to be cutting out of it. You know, well, it is actually running into problems right here. That's probably part of it, but I really can't do anything about that. That could be what's causing it to fail, is this curve intersecting with this right here. It's just not liking that. It's probably what the cause is. And again, you know, if you got the tens of thousands of dollars, you know, $5,000-$10,000, you can go buy a really good program and not run into problems like this. But, you know, like SolidWorks or something like that. But, yeah, there's not really a lot I can do about this. Like I said, I should have did that lip earlier. You know, that's usually the first thing I do, but I just kind of, you know, forgot. You know, with having a headache and everything else. Like I said, the only way to correct it is to redraw the whole fucking thing. So, which I'm not gonna, not even gonna think about entertaining that. So I'm just going to have to glue it down and eyeball it the best I can. Let me get rid of all this crap. So what we'll do instead then is oh, now what? But now it can't extrude a fucking circle? I don't know about these fucking idiots. Okay. Shit. Just about right there, so You fucking piece of shit. So what the fuck's going on here? Fucking piece of shit. What do you think I'm trying to select, you piece of fucking garbage? Okay. Fucking piece of shit. Okay, now let me take this, extrude that out. If I can make a skirt for the other side. Alright, then we can go and hide all this garbage, and that's the piece with the skirts on it that we're after, if we can get it to successfully weld, which who knows. Probably should have saved it first. Okay, well, it looks like it did successfully weld. So if I light the bottom up, you can see that it acts like a well, that's not going to work. Damn it. What the fuck did this... That's more like it's supposed to look, but apparently I've got to do this all over again. Damn it. I mean, really? You stupid piece of crap. and this is, giving us enough room to take into account for the fact that parts will be fatter than we think they're going to be on 3D printing. So it's a little less apparent. These big gaps are a little less apparent in an actual print than they are here in the more precise CAD world. Let's see, that provides our, because how I had it before, if I would have done that, basically the parts wouldn't fit together and I have to go carve them up, so, with nippers or something, I don't want to have to do that, so. At any rate, that's our skirt adapter ring. That's that, so basically, I can pretty much light everything up at this point so we can get everything kind of positioned. At this point I can pretty much grab everything up there and we will reposition it. Now to join this. Okay. So that's our light so far. So at this point, you can see the battery is sticking at the bottom, so I have to move that down. This is going to be a pretty tall thing. You can kind of see that, with the lens extended, to its topmost position. That's about 1, 2, 3, 4, 5, 6, 7, 8, 8 or 9 inches. With the battery compartment, be at least 8 inches tall with, with the diffuser down. So it's going to be a pretty large device, which really just can't be helped given what we're doing here, so bigger than I like, but that's why I got to put a flared bottom on the thing because of that fact. We don't want it tipping over too easily. Anyway, at this point, we'll have to have this piece here glued to our upper battery compartment housing, which will have a thread on it, and then below that we'll have the lower battery compartment housing, which will have a joining or mating thread with it. So we'll pick up that project tomorrow.